Hi all, welcome to lesson 10. Let's get started with the warm-up. This says, find the slope of the curve y equals 1 over x plus 1 at the point 2 comma 1/3. First of all, we need to understand that y is same thing as f of x, right? So that's one thing, and more second thing we need to know is that we're really concerned about our x coordinate. So we want to find the slope at the point x of this curve at the point x equals 2. And how do we do that? How do we find the slope of any curve? We use this different quotient that you learned in your last lesson, and that's the whole formula, which I wrote it out here. This is what it is, right? Limit as h approaches 0, f of x plus h minus f of x over h. So I already know f of x is this whole thing. It's this thing, right? So I want to find f of x plus h. So I'm going to do it here. F of x plus h. So wherever I see x, I'm going to substitute h in there. So that's basically it, right? So I don't have much simplification to do here. It can be rewritten as 1 over x plus h plus 1. Now I'm going to substitute this into my difference quotient, and what do I get? So it's gonna be limit as h approaches 0, instead of f of x plus h, I'm gonna write 1 over x plus h plus 1 minus 1 over x plus 1 all over h. Right, so now I need to do some algebra in the numerator. I need to simplify it. I'm going to take the common denominator, and then I'm going to just simplify it from there. So what am I doing here? What's my LCM? My LCM is, I'm going to do limit as h approaches 0. My LCM is x plus h plus 1 times x plus 1, right? So what am I doing here? I multiplied this denominator by x plus 1. So I'm going to go do the same thing in the numerator. Here I did x plus h plus 1, and I'm going to do the same thing here, right? So what I'm going to write here, I'm going to write here, this would be x plus 1 minus. So now be very careful. I have this minus here, and I'm going to distribute this negative over each of these terms, right? So it's going to be negative x, so I'm going to write minus x minus h minus 1, right? So now and this is all over h. Let's finish that. What happens in my numerator is that the x's cancel out and the 1's cancel out, and I'm left with limit as h approaches 0, negative h over x plus h plus 1, x plus 1, right, all over h. And that's where I do my keep, change, flip. So if I do that, what do I get? Limit, I'm just going to take a different color so it's nicer. Limit as h approaches 0, it'll be negative h over x plus h plus 1 times x plus 1, and if I flip it, it'll be 1 over h, right? So my h's cancel out, I'm left with a negative 1, and I'm left with limit as h approaches 0, negative 1 over x plus h plus 1 times x plus 1, right? I'm hoping that we all get this math. And then what are we left with? We can just simplify, we can apply the limit, and it is what? Negative 1 over x plus 0 plus 1 and x plus 1, right? Which is negative 1 over x plus 1 square. right? Now I want to find the slope at, I'll just change the, at x equals 2. That's why only the x value mattered. The y value wasn't even, we weren't even interested in it. So all I'm going to do is substitute 2. So it'll be negative 1 over 2 plus 1 square, which is, simplify it and you get negative 1 over 2 plus 1 is 3. 3 squared is 9. Negative.
So today's lesson, lesson 10, we're going to be talking about what is a derivative. Derivative is basically the slope of the tangent line to the curve at a point. I'm going to do a quick sketch of it, and I hope that makes sense to you. So let's say I'm going to do it here. I have this curve, right? Do you see, if I was to find the slope of this curve, it's going to be different at different points. So if I'm given a point, I'm going to do it in red. I'm given a point, and so this is what we've been doing in lesson 9. We've been finding the slope when x is a certain value. Let's say if x is 2 here, we're going to use the curve. The equation of the curve is given to you, and you are finding the slope at that point. Now, today's lesson, we are going to find the slope of this line that's tangent to the curve. But think about it. Isn't the slope of the point and the slope of the tangent line the same at that point? So it's the same idea, but that's what the derivative is. It's the slope of the tangent line to the curve. So I want you to pause the video and copy all this. And I just want to quickly talk about what it is. The limit used to define the slope of a curve at a point is also used to define one of the two fundamental operations of calculus called differentiation. Differentiation is a very important topic in in calculus. So we will be doing a lot of it. We'll be doing a lot of rules with it. So this is just the beginning of it. So the derivative, which I told you is the slope of the tangent line to the curve at that point, is represented by this. That's the notation, and we read it as f prime or derivative of f of x, right? And what's the definition of it? The definition is f prime of x is limit as h approaches 0, and that is your difference quotient that we have been studying since the last lesson, given the limit exists. Other notations besides f prime of x is included here, so these are different. Copy them into your notes. Example 4, it says, applying the definition, find the derivative of f when x equals 2 of the given curve. So I wrote the definition already, the difference quotient. So the first thing I need to do is find my f of x plus h. So I'm going to take it up here, and I'm going to substitute x with x plus h, and what do I get? So wherever I see x, I'm going to substitute it with x plus h square minus 1. Expand that, and what do you get? I'm just going to do it here. It'll be x squared plus 2hx plus h squared minus 1. Distribute the 3. So the final thing I get is 3x squared plus 6hx plus 3h squared minus 1. Right? I like to do it on this side because it saves me all the trouble. It's like very confusing, and I do it with the question for some reason. Anyway, so I'm finding the derivative, and that's the notation. Please refer to your notation, understand what it means, know how to read it. Okay, so now what do I do? All I'm going to do is substitute each of these things. I'm going to substitute this with this. I'm going to substitute f of x with, this is my f of x, with this, right? So I'm going to do that. So let's do this here. I'm going to take this color, and I'm going to go. So f prime of x is limit as h approaches 0, 3x squared plus 6hx plus 3h squared minus 1, right? Minus, remember, when I'm substituting f of x with this function, I have a negative outside, so I have to distribute that. So it'll be negative 3x squared plus 1 all over h. What happens here? Look, the non-h terms I would say will all cancel out. So 3x squared, oh, I changed colors, didn't catch it. Cancels with 3x squared. The negative 1 and the positive 1 cancel out. And what am I left with? F prime of x is limit as h approaches 0, 6hx plus 3h squared over h. I'm going to factor out the h, so limit as h approaches 0, factor out the h, and what am I left with? 6x plus 3h over h. Right? I couldn't apply the limit in this step because if I did, my denominator would have been 0, and that is not defined, so we couldn't do that. So that's why we had to simplify it further. Okay, always keep that in mind. Anytime you get a denominator of 0 and when you're working with limits, you want to, there must be more simplification to do. So the h's cancel out and you're left with, apply the limit. So it's going to be wherever I see h, I'm going to be substituting with 0. So I'm left with this. So this is what? So f prime, the derivative of f of x, or you can read that as 6x. So now at x equals 2, because that's what we want to find it, right? At x equals 2, what would it be? Just substitute it in there. It'll be 6 times 2, which is 12. So that's how you're going to do it. Sometimes you might have to rationalize if you have radicals in your practice problems. So kind of simplify it. If you have fractions, right, add up the like terms, subtract the like terms. So there'll be like different combinations for your practice problems. They will require some time. So take your time, do those, and I'll see you in the next video. Have a great day. Bye-bye.